On this page, we're going to do a little bit of review and then also extend what you did on the homework. So it says, from the previous lesson, write the values of the following trig functions. You should see in your packet that this is fine, but this just says 30 degrees in each of these spots. It just didn't convert well over to the file. So the sine of 30, and we should know this from our chart, just going across, the sine of 30 is 1/2. The cosine of 30 is radical 3 over 2. And the tangent of 30 is radical 3 over 3. Now we're going to draw a 30-degree angle. So this also means 30 degrees on the unit circle. So there's our 30-degree angle. We're going to draw a vertical line from the point where the unit circle intersects 30 degrees to the x-axis. You now have a triangle with its base on the x-axis, so this should look familiar. How long is the hypotenuse of the triangle? So we know since this is the unit circle, it's the radius also, so that's 1. Label the base of the triangle x and the height of the triangle y to correspond to the point on the unit circle that intersects. So we know that this is x, y, and that's why we can label these x and y, because however far we went over is the x value and however far we went up is the y value. Now we're using the 3 labeled sides, the 1, the x, and the y, to find the values of the following 3 trig functions in terms of the labeled triangle. So we already know the values of the trig functions up here, the actual values, but if we just use this labeled triangle and the fact that this angle here is 30 because we went through this point, we get the sine of y, or sine of 30, sorry, once again that weird looking angle, is y over 1, which is just y, and that comes from the fact that the y is on the opposite side and the 1 is on the hypotenuse. X is the adjacent. So for cosine of 30, we get x over 1, which is x. And for the tangent of 30, we get opposite over adjacent, so y over x, which doesn't reduce. So what we're seeing here, and what we talked about also in the homework, that is because the hypotenuse is 1, it cancels out, and the sine of any angle theta on the unit circle is equal to the y value of the point intersected by the angle. So I know that sine on the unit circle, sine of the angle, is also the y value of the point. In the same way, the cosine of any angle is x for that point. So putting these two together, putting these 3 facts together with these 3 facts, therefore any point on the unit circle intersected by an angle of 30 degrees is, the x value is the cosine, and we know the cosine of 30 is radical 3 over 2. So in the spot for x, I can write radical 3 over 2. The y value is the sine. We know the sine of 30 is 1/2, so that means that point, the y value of that point has to be 1/2. And if we look at it and we think back to that first lesson where we talked about on the unit circle, would the x or the y be bigger at each of those points? If I take this point, radical 3 over 2, 1/2, that makes sense because we have that larger x value, smaller y value for that point, and now we know the exact value using the sine and cosine of 30. Extending this reasoning, we're going to talk about what the points are for 45, 60, and then we're also going to talk about 90. So I'm going to keep it right here. 45, and we're going to write it this way. So we just showed that any point on the unit circle, the cosine of the angle is the x and the sine of the angle is the y. So when I'm at 45, we know the cosine and the sine of 45 are radical 2 over 2 from that chart. So the point is radical 2 over 2, radical 2 over 2. And that should also make sense because we talked about how that point on the very first day, that point at 45, the x and the y look about the same, and they are exactly the same. Lastly, for 60, the cosine of 60 is 1/2. the sine of 60, right, sine goes in for y, is radical 3 over 2. So those 3 points, now we've taken those values from our special triangles, the sine and cosine values we found, and we put them on. Notice tangent doesn't really come into play. We could just use the point and do y divided by x, which we now also know is sine divided by cosine, to find the tangent value. The last thing on this page, we're going to talk about what the point is at 90. And that was one of the very first things that we did. So if I look at my unit circle, this point up here by 90, let's get a pen color. We said in the very first 5 minutes of the unit that we know that point is 0, 1. Okay, because it's located up, right, 1 up from the origin. Now, it sounds weird to talk about a sine of 90 or a cosine of 90 because we really only know about trig functions up to this point in triangles, and I couldn't fit another 90-degree angle in a right triangle that already has one, right? That would make up 180 and I wouldn't have room for anything else. But using the fact that the y value is the sine on the unit circle, the sine of 90 is 1. In the same way, the cosine of 90 degrees is 0. And if you typed these in your calculator, making sure you were in degree mode, if you type the sine of 90, that will give you 1, and the cosine of 90 would give you 0.